So, hello, welcome back to our course, Technology Forecasting for Strategic Decision Making. And now we are going to learn about system operator and why it is useful and what is the usability of system operator for technology forecasting. In fact, in border of process of technology forecasting, we need to define boundaries of our system to forecast. And this is not easy task, because if you're talking about kind of vacuum cleaner, okay, you can see this compartment. This is a physical boundaries. But if you are talking about public transportation system in your city, it is not so easy to define boundaries of this system. So in order to deal with this question, how to define the boundaries of system to forecast, we can purposefully use a system operator. And the system operator, this is a technique which has another name in English literature, multi-screen schema of powerful thinking. The first time this technique was suggested for creative thinking by Mr. Henry Altshuler, father of theory of inventive problem solving, in his book Creativity is Exact Science, the Theory of Solution of Inventive Problem, which was published first time in Russian language in 1979. What does it mean, and what are the dimensions of this system operator? In fact, the system operator suggests you to describe your system using kind of virtual screens. Okay, at the central screen, we put our system and we try to define what are the components of our system and how they interact among each other. But the upper screen, which is super system level, we put the systems which need our system as a part. The system that cannot provide its functionality without our system. So we have at least two levels, the system level and time level, because it is asked not only to represent what is the system which need our system to function and what are the components, but it is also asked to describe the past of our system, and using knowledge about past, present, we can project some tendencies which will be in the future of our system. So as a minimum, those kind of this system operator include at least 9 screens, but for different purposes, the number of screens can be increased. For instance, if we are studying social impact of our technology, we need to go much more in the super system to the society in order to see how our system serve the society needs. Or if we are making long-term technology forecast, we go several dimensions in the future. If we're making study about history of evolution of technological system, we can go in the past. So the system operator is not limited by these 9 screens. And you can see behind of each screen something that looks like shadow, and it is not done for the beauty. The idea is that the system operator, this is a multidimensional schema. Let me show you example in order to make it clear how you can use this way of thinking in practice and how it helps us to define boundaries of our system. At the central screen, we put our subject that we are interested to study. For instance, if you would like to make a study about the chair in a classroom, we put our chair or office chair on the central screen. Of course, this chair has a seat, it has back, it has a structure. Those are the components. It's quite straightforward, and you are used to describe your system like that. But what is also important to describe what are the systems which need your chair. For instance, whatever office you have with a desk, it doesn't work if you have no chairs. If you use a computer, you need a chair in order to sit comfortably and stay in front of your screens. So we need to describe the system, which include those description helps us to envelope and define our system, not only through each function, but also through the components. Let us see one of the example about classroom chair. Okay, how system operator can be fulfilled for the classroom chair. First of all, we have to define the purpose of running system operator and the viewpoint, because depending on the purpose and depending on the viewpoint, the content of each screen can be very different. In our case, the purpose was to improve the classroom chair for students, not for professors, but the classroom chair which are used by students. And the viewpoint were the students, which are clients of this classroom chair, and the designer who designed this classroom chair. The function of classroom chair was defined to support students' body in learning condition, and this is what we put on the central screen. We also put the inverse function, because whatever system we took, we always have a direct function and inverse function. This is something which comes from system theory. And the inverse function or opposite function is to liberate students' body in learning conditions. So we have to support students' body and we have to liberate students' body at the same time, depending on the changes on the condition. Okay, the structure, sit and back support, structure of the chair, action, reaction, flow chair. This is something which is very essential. Without this, we cannot support students' body. And rigidity of the structure, which is described through its feature size of chair components, weight of, and those are, they have certain values. So what are the nearest super system? What are the nearest system which need our function to support students' body, and without this function, they cannot perform their functionality? The classroom with tables, the sharing information process, when we need to take certain place in space within certain amount of time, and doing work on the table. When we are doing something on the table, we need to have a chair in order to support our students' body. If you put, for instance, the present for 2012, we take life cycle of the chair is about 10 years, okay? So we step back into the past for 10 years, which is once again, it is not a random number, it is number which correspond to the life cycle of chair in a classroom. And we see how it was different. The main idea is to disclose what was different in the past. And we can see that in the past, the classroom chair for students were less comfortable, more rigid, and not adaptable. So they didn't change their behavior. So, and sit and back support was mostly from the wood. Structure of chair was just two materials, and we had a student's weight. Floor material was not absolutely the same that we have today. Today we have more new materials for the floors, and the size of the component was a bit smaller and weight of components was a bit heavier. Okay, and we see that in the past, and this is very important to capture in order to define our system, that in the past, on the level of the super system, we also had some differences. The classroom with tables, the arrangement of tables was different. We had a smaller tables, they were differently arranged. We had a sharing information process, mostly it was a face-to-face, without computers, using Blackboard. When today it is less face-to-face, in a condition of pandemic, we have mostly distant interaction, and doing work on the table, writing on the paper, this was main activity. And today, even for 2012, it was doing both, doing something with your computer devices and writing on the paper. So all those changes, we capture them and we try to see how those trends from past to the present will continue to the future. And we can see that in the future, the classroom will be more virtual classroom. The table, little by little, will be transformed to the touch screen table. The process of sharing information will be more distant, less face-to-face hours, and will be more flexible. More flexible on demand. It means our students can participate face-to-face session, or they can participate asynchronous distance session or synchronous distance session. This is what does it mean on demand. And doing work on the table, we will work most of the time with screens and very little with a paper. Okay, so those changes in the super system inevitably will lead us to the changes of our classroom chair for the student. And will it be classroom? If it will be distant classroom, the chair for the students will be different. Okay, and when we depict our system this way, we define not only function of the system, but we envelope our system because we clearly define what is the input, what is the output for our system, and we can predict how this function will change in the future. What will be the technology, what will be the system that will answer all those requirements? Of course, we will have some requirements from the subsystem, but as soon as they are more easy to figure out, I don't spend so much attention with them. By the way, we take care about how students' weight is going to change, how size of our device is going to change, and so on. We always have to take accountable. When we run our system operator, another very important thing to keep in mind, that system that we try to define, system to forecast, is a part of a process. And this is a very important postulate, that everything is a process. Whatever we define, we have to define it not only in space or in structure. We have always defined it in a time. So that's why system operator describe a system with a past and future dimension. What does it mean that a system is a part of the process? Whatever system we analyze, we have to keep in mind that we have the super system. This is a process which need our system as a part. If you just remove this part, this process cannot be performed. This part can be, but this one not. So these two boxes, they can be considered as a neighbor system. They don't depend so much from our system functionality. When this box in the process is entirely super system which need our system as a part. So very important to keep in mind when we define the system, that we have to define what are the input for our system, what are the output, and what is the transformation which happen. This is exactly what we already discussed when we discussed about function of the system. The function of the system, that is one of the key feature of our system. Do you remember we put it in the central screen of our system operator in order to start description of our system without specific terms. Up to now, if no questions, I can go further. If any questions, we can answer them within our webinar, or we can discuss it right now.
I have one quick question.
Please.
Sorry. I noticed that changes in future super system you have from super system of present to the future. Does it necessarily reflect on the future system as well? Is it necessary?
Yeah, in fact,
that relationship.
Yeah, this future system, you can see the errors, they are in the both side. In fact, how the future system will look like entirely defined by changes on the super system levels. In fact, what will be the future state of the system depends not on possibility what we can do. That very often we can do very interesting, very amazing things, but if as soon as they are not required from the super system, they will never take place. This is one of the explanations why so many inventions do not appear as innovations. Do you remember our distinction between invention, which is feasible, which can improve ratio of performance to expenses, but innovation, this is when we start running the production and when we have a market. Because in fact, what will be the classroom chair for the student depend entirely on the changes on the super system level. So that's why we have to describe nearest super system changes as much as we can. Did I answer your question?
Yes, you did. Yes, you did. Thank you.
Thank you. And using the postulate that everything is a process, it becomes even more clear that our system is an embedded part of the process, and we always have to see on the changes on the process. But let us see one more dimension, because before we saw just how to use our classroom chair. But the very first slide about system operator, I told you that there are many dimensions in our system operator, because if you look at the dimension of life cycle, we can see that at the beginning of the life cycle, when we design a new chair, okay, the super system, this is a designers and a team of designers who suppose to develop the new design and new kind of components. When we start manufacturing, the super system is changing. The super system, this is a factory, and the process to produce different components, those are the subsystems. When we deliver our system, we have a warehouses, we have a transportation network, and our system is once again changing. Okay, and we have a subsystem like packaging, like components of the chair, and so on. When at time of utilization, this is exactly what you've seen on the previous slide, description, how do we use our classroom chair or our office chair. And we have a different components, and here in the utilization, I'd like just to recall to our definition of the technology to remember it is not enough to have an artifact, we have to have knowledge how to use it, and we have to have regulation how to use it. I mean, rules how to use it. Okay, and this is exactly the issue, not only within utilization, this is an issue at each stage, because we have to have knowledge to design, we have to have knowledge to manufacture, and we have to satisfy certain regulation at each step, and the transportation and on the delivery also. But one more dimension, which we can build once again more than 9 screens, this is a maintenance and recycling, because everything that begin, everything will end sooner or later. So when we design our chair, we have to also take into account how are we going to make maintenance and recycling of this one. And once again, the super system for recycling our chairs is not the same as a super system when we use it. And the subsystem are not the same as here. So in fact, if I just look, you have 1, 2, 3, 4, 5 dimension. And this is, if I just go back to the general schema of system operator, this is a 5 dimension that we can extend in a 3rd dimension, our system operator. For the purpose of technology forecasting, first we use the 1 or 2 dimension in order just to define our system, like it is explained on the example on this slide. The main idea is to define our system boundaries in order to predict future without being driven by biases and preconceived ideas based on its function and based on the transformation in super system and abilities to produce necessary components and organize necessary interaction. This is mostly all that I would like to share with you today about a system operator. Of course, it's interesting to practice it, and I believe for some of you who are interested about technology forecasting, an advanced course about technology forecasting for strategic decision when developing your project, you will have a good chance to develop system operator for your technical system. Thank you very much for your attention.